Everybody. I see some people I haven't seen for a while here. Very nice to see you again on this Zoom meeting. Thanks for spending some time with me. Some of you will have heard varieties of this talk maybe before, a couple of you anyway, but it's a topic I feel like I still have to talk about because it seems like the industry is still not getting it. But at any rate, so here I am talking about one of my favorite topics, the technical side of Agile. A little bit about me. Behind me is a skyline of Chicago from the lake. That's where I'm from originally, the Chicago area. But now I find myself near other water down in Florida, and where there's exotic trees, and that monster was in my backyard a couple of years ago. We get his little brothers and stuff now, but and then sometimes some bad things happen down here, like hurricanes. But generally it's pretty nice down here. So that's where I am. Let's get into the topic. And so it seems that there's a lot of pain still around developing in an agile world. So I thought I'd give you a little bit of my background. Oops, let's see, wrong picture. Wrong button got clicked. We'll do a little Wayback Machine for starters. And if you're not aware of who these two characters are behind me, that's Peabody and Sherman, and they go in the Wayback Machine. As a kid, I grew up with these guys, learning history in kind of a fun way. But I tried to I wanted to stay away from computers back when I was in high school. I saw somebody programming. It looked like a terrible thing. So I tried to avoid it. And unfortunately, fortunately, in college, I had to take some programming. And I found out that it was fun as I'm solving Newton's method for finding the area under a curve instead of having to do it the long way. I was able to do it in BASIC, and it turned out it would be fun. And somebody would pay me for that. It was kind of shocking to get paid for something that was that much fun. I walk into my first job, they hand me this 8251A data sheet, and I become an embedded systems engineer trying to program something where you have to toggle in zeros and ones. Luckily, the guy I was working with knew how to do that, because I am not that detail oriented enough to get that right. Pretty primitive, some of the tools that we use. The turnaround time, if you made a change to your program, you had to first shine UV light into your proms, and then you had to burn them. It was a long turnaround time. And debugging tools were kind of primitive. If we had a serial port, that would have been really nice. We could have used debug statements, but we didn't have any of that. So we did have debugging, it's in-circuit emulation and such. But so that's where I started. That was a long time ago. That was in the late 70s. Now, around the turn of the century, I got introduced to extreme programming by these fine people, and really changed my world after 20 years of experience of doing something I call debug later programming, which I'll explain to you a little bit more when we get into the talk. Ran into extreme programming. It seemed like it solved a lot of the problems that we were experiencing. And it was a technical thing. And then, a couple of years later, Bob says, "Hey, James, you want to go to the Lightweight Method Summit in Snowbird, Utah?" And I heard the word Snowbird, Utah. And of course, yeah, sure, Bob, what were we going to do there? Yeah, I can make it. And it turned out there was at the time, a lot of effort was going into software processes. And there were some, a lot of energy going into process improvement teams and such. And the message that it seemed that people were getting from works like Humphreys, and I don't know that this is what he intended, might not be what he intended, but the message was, if we just had a better process, the people wouldn't matter, right? We could do these great designs, and then we could email those designs to cheap places to get it coded, and the world would be wonderful. We'd save money, and people wouldn't matter so much as long as we had the right process. And it wasn't really delivering, and processes seemed to be getting heavier and heavier. And extreme programming and Scrum were a couple of the flavors of ways to work in a more iterative and incremental way, a way that seemed more realistic. And so these statements came out, which you people have heard of before, so I'm not going to spend time on them, except for the first one, which was kind of disturbing for a guy who's an engineer, this people thing, right? Now, the people have taken over Agile pretty much, and the Scrum people have taken it over. And, where's this extreme programming part still? Well, I'm getting to that part of the story here, because as an engineer, that's the thing that drew me into all this. Oh yeah, we happened to host the first ever Scrum class in 2003. And what's happened to Scrum, since then is there's been a bunch of Scrum Masters that have been certified. And here's the old data from 2014. I'll get to the new data a little bit later. But what was Scrum supposed to do? Well, Ken says it's supposed to expose every inadequacy and dysfunction within an organization so that you can fix it. Skipping a few words there, right? You're supposed to find the problems in your organization and fix them. And I know in the beginning days of taking extreme programming to people, what we would do is try to find out what problems they were trying to solve. And usually they were, we're late a lot and we deliver poor quality and everybody's getting burned out from these death marches. These were the top problems we'd run into. And the logic chain from extreme programming to solving those problems was rather short if you're willing to try it. Now, that was 25 years ago almost. Not many people were willing to try it and still aren't. But at the core of Scrum was supposed to be something which I'd seen before, continuous improvement. If we paid attention to how we're working, identified problems, and really tried to fix them, life will get better. Now, what I think most of the Scrum community is doing, and our sponsors I know are teachers of Scrum, but I think in practice, what's happening is there's a lot of do going on and not a lot of PDCA. So we're doing it, but we're not improving as much as we should. Of course, that's a statement which there's places that are improving, of course. Now, 10 years after the Agile Manifesto, there was another meeting to kind of celebrate and find out what was wrong. And the question, much more formal, kind of a thing that happened at the Agile Manifesto debrief 10 years later or celebration was we started to ask, what do we need to fix? And so there was a professional facilitators instead of just a room full of nerds facilitating on their own. And we came up with 4 bullet points. That was, I think, by design. Somebody said, we need 4 new bullet points. Okay, 4 bullet points. I only remember the first 2. Demanding technical excellence, like how do we get better at iterative and incremental software development? And how do we help people change? Because that's not the way people learn. They didn't learn how to engineer this way, right? Well, let's see. So what else does Ken say here? The intention of Scrum is to make the problems transparent so you can fix them. But Ken, what's really happening? Unfortunately, organizations change Scrum to accommodate their inadequacies and dysfunctions instead of solving them. Now, that second statement makes me think you're not supposed to change Scrum, but the whole purpose of Scrum is to start this continuous improvement loop, which means it's going to change. It needs to change because it's kind of empty. The Scrum cycle is about the planning and teams and ceremonies and such, but it doesn't really give you much guidance on what to do. So we're still, I think, suffering to some extent. And when I go, well, I'll show you some of these things I've bumped into on the internet to maybe support my claim there. But so here we're iterating now. And I've heard that there's a thing called hardening sprints at the end of iterations before you release. It's like when you save tests to the bottom of the waterfall or till the end of all the cycles of Scrum, right? Before you start to release. So here I am down at the bottom of the waterfall, trying to catch some bugs, hunting for bugs. And so the job keeps getting a little bit harder as we find more things, having to react a bit more. And keeps getting hotter and hotter. And eventually that waterfall that was nice and peaceful, we find out it's not so peaceful at the bottom of the waterfall, right? We save that testing until the end. Or if we're relying on manual testing, we're having to retest at the end. And what happens? Of course, we find some problems we're expecting to. And then someone says there's just one more bug. And then what happens? Well, then it really gets interesting when they claim there's one more bug and the firefight starts. And, so here's these firefighters. Come on, go backwards. Go ahead, start moving. These guys are disciplined. Look at them. They're working as a team. They're putting out the fire systematically. Our software developers so systematic and so disciplined while they're putting out the fires that they just started in their code bases. And I wonder, why does this happen? Is this inevitable that we have to be chasing down these problems late in the development cycle? And then somebody will tell you, don't worry, we're 90% done. Everything's gonna be fine. Now, Jeff, he's a realistic person as well. He says the biggest problem worldwide with Scrum teams is getting shippable code at the end of every, I hate to say this word, sprint. Sprint gives the wrong connotation, but I'll try to not say it again and show you why I object to it. People are in the do cycle, right? Doing Scrum, okay? It makes it seem like all that matters is the deadline. If what you want to do is sprint and stop and deliver something, measure velocity, all these things, we're getting the idea that what's important is going fast. So iterating, delivering really quick, it sounds great to the management. They want things delivered quick. So Scrum is supposed to give it to me. I can ask for things every 2 weeks. So you're changing the cadence of delivery. I know before Scrum and Agile, we in the PDCA of TQM back in the late 80s, early 90s, my boss came to me and said, when are you guys going to start doing this TQM now in software development? I said, well, our cycle time is 9 months. We can't do that. It's like, oh, okay, you can't do it. Your cycle time is too long. Now we've changed the cycle time. Have we changed engineering to support the cycle time? I wish I knew now what I didn't know then, because we can do iterative and incremental high quality work. And if you're just being managed iteratively and you're not engineering iteratively, then you're going to feel the pain. And so here we are back to Scrum, and they've introduced the idea of certified Scrum developers, not just certified Scrum masters. So this slide is kind of old, and I updated some of the numbers today on the next slide. But notice back in the old days, 10 years ago, 1/3 of a million Scrum masters and 50,000 Scrum developers. And what conclusion can you draw from that? I'll tell you my conclusion. It takes 6 Scrum masters to master 1 Scrum developer. We got to be managed, right? Okay, well, what's happening today? Well, let's see. So the acronyms have changed. They're PSMs now, Professional Scrum Master. I think that's what that is. And let's add up those numbers. That's about almost 700,000 professional Scrum Masters. And let's see about the Scrum product owners. We've got a couple 100,000 more of those. Let's see, what's the total at 885,306 as of the Scrum site this morning. And let's see how those Scrum developers are doing. If that ratio stayed the same, that'd be interesting, except it's gone down. Now there's not even 20,000 professional Scrum developers. So now it takes 46 of the PSM PSOs to master and own the Scrum developers. Something's not right here. Something's not right. When you send everybody off to Scrum Master school that isn't a developer, and the Scrum Master comes back, developers are going to feel like they're being micromanaged. We got to meet every day now and update the Scrum Master. Well, I know I'm telling you dysfunctional things, but because there is dysfunction out there that I've seen. And after you sprint, guess what happens? Well, here's the sprinters that have all collapsed, right? Because they're out of oxygen. And now the Scrum Master comes by and says, what was that velocity? Can we do it again? We need better velocity. And we start to not really know how to manage our capacity. And so here's somebody that only knew about how to write all the code all at once and then make it work. Well, and they got crushed and they're not quite sure what's wrong, but something's wrong here. So we got to start to we're not doing such a great job of bringing development into an agile way of working. There's a lot of people complaining about the lack of quality and the focus on time only in that. Well, it's pretty natural because no one has really been taught how to do iterative and incremental development. Here's some guy who I ran into online a few years ago, 2016, and he had this rant about something that wasn't agile, but was agile in his company. And if you look at, he had 500,000 views almost. A lot of people liked it. A lot of people commented on it. I commented on it. Not that many people cared about the positive view of Agile that I might have, as compared to the negative view. The negatives were definitely winning on this battle. More engineers are not liking Agile than are liking it. So here's this pain scale that you might have seen on the front page here. So if you start asking people to deliver iteratively and what they've grown up with is waterfall, they're not going to be very happy about that. They're going to feel like, well, they don't know how to do that work. They've never been taught how. And so what the pain scale here shows is, as you learn these techniques, you can change that into somebody with a bright future. So now let's see, where am I doing on time? 22 minutes. Okay. I was out to dinner after some conference, 10 or 15 years ago, and I was talking to somebody, and it was a business person. So I usually use that as my opportunity to say, the world's only doing the easy half of Agile. And the guy says to me, what's the easy half? And I said, oh no. He said, what's the hard half? And he says, what's the hard half? So I say, well, the hard half is the technical side. That's not the hard half. The hard half is the people side. It's like, oh, move over planning and technical excellence. There's a third half, respect for people. And it's like, oh, yeah, of course. An engineer, I kind of ignore that, but there's the mechanics of planning. There's techniques of iterative development. And then we got to be respectful of people on how they learn how to do this stuff and how we interact and how we treat them. It's not my world because I'm just an engineer. But if you bring extreme programming practices into Scrum. Now, we asked Ken Schwaber in the first ever Scrum Master training that happened at Bob Martin's company back in 2003, which I showed you a picture of before, why don't you put extreme programming into the definition of Scrum? He said, well, we don't need to because we've got the retrospective. And at the retrospective, people are going to say, we've got these problems, and then they're going to either invent techniques for dealing with it, or they're going to go off and find extreme programming. Well, this doesn't really happen that way, right? So here's a set of practices really centered around test-driven development, collaborative work, keeping things simple, refactoring. The core of these practices are the core engineering practices. And you can see them largely unchanged and somewhat evolved. Some of the practices have evolved today. And one of the things that I think will be interesting because of the focus right now on continuous deployment and such, people wanting to be able to deploy features regularly, I have a feeling that might help pull in extreme programming. It's kind of a natural conclusion of extreme programming. Actually, there were companies doing this in the early 2000s that had their pipelines going all the way out to a DVD being produced. It could be plugged into a machine to take the new load of code, the new functionality, all automated. So there's a natural, maybe the pull is going to happen, I'm hoping. So this marriage, I would suggest, let's bring these two ideas together. Now, what is the current way of working? So I interview with a survey people that take my training course on test-driven development for embedded C. And I ask them a few questions, and one of them is kind of an open-ended question, but tell me, how much time do you spend, what proportion of your time is spent in coding, testing, and debugging? And I get these numbers, and you'll see there's a wide range of numbers. And some of these stand out, like 10% coding and 60% debugging, or 10% coding and 70% debugging. These numbers aren't scientific. These are just people's impression of where they're spending their time. And then usually down here, there at the bottom, there's one guy who's got a cycle time that's pretty low and is not spending much time doing debugging. And usually that's a person that discovered test-driven development and extreme programming and, kind of brought a guy like me in to help out. How long does it take for you to build your code, right? People are spending a lot of time waiting for build systems. Maybe this has gotten better since I put this chart together, but this is based on data from people, embedded systems developers that take my training course. Maybe it's better in other parts of the industry. I'm not so sure about that though. So one of the other questions I ask is, how do they test their code? And they're doing an amazing thing like looking at log messages, or having print statements in their code, or single stepping with a debugger. Some of the things, or using a logic analyzer. Now the logic analyzer is a little thing that plugs into a USB port, and instead of a $50,000 piece of equipment, now you can just plug it into your computer and get a lot of the same stuff. But you know what? It's pretty much like the old stuff, except just newer. And so I'd like to congratulate developers for using 1979 development techniques. Good job, guys. All right, so debug later programming. That is the technique that's been around for quite a while. One of people I love to quote, John Gall, your program will have bugs and they will surprise you when you find them. So here is, what happened now? Stop moving. I must have moved my mouse. There we go. So here's a party. Well, here's the party at the end of a release, and you can see the engineers are toasting with some champagne, and a bug pops in to destroy the day, to ruin the party. And the lead developer there hacks the bug. I mean, engineers a solution to that bug so they can get back to their champagne. And let's open up another bottle of champagne, of course, chop it off with a machete, fill up those glasses, and they don't even realize they're surrounded. They just found one. They thought they were all gone after killing 1,293 of them. You know, where did these bugs come from? Look at this set of headlines here. Can anybody put into the chat something they know that's common about each of one of these headlines? I'm not going to wait too long. And there is a common word in all of them. The word is glitch. Now, glitch makes it sound like it's nobody's fault. It's like, oh, you know, another one of those acts of the universe just happened, and now there's 625 hybrids that have to be recalled, and 787s that, you know, shouldn't be flown for very long. Glitch, yes. No, not a glitch. I'm sorry. Can we admit there's a problem? No one knew. So what I'm going to ask you all to do is, with me, if you're a programmer, let me change my view here. Well, I'm going to keep, let's back up a little bit. If you're a programmer, stand up and repeat with me. I'm a programmer and I write bugs. Unmute those microphones. I know somebody is in charge. Muted the microphone. So you're all saying it to yourselves. If you want, you can tweet it to me. Okay. I write bugs. All right. So now that you've made that admission, you developers out there, let's start taking apart our problem. If we do development, write code, followed by test, guess what we're going to find? We're going to find defects. Are we going to find all of them? Well, probably not. We're not going to find all of them. We're going to find some of them. You know, it's not our fault. Let's do a debrief. Is it our fault? Well, yeah, it is our fault. We put them there. A lot of people like to blame someone else. Okay, it was there before. This is a messy code base. It's not my fault. The way we work adds to the problem. And here's the most popular way to program on planet Earth that I've seen, and I call it debug later programming. Now, don't put that on your resume. It's not a serious term. It's, you know, one of these joke terms that you put together when you're writing a book. It's shorthand for the other thing that's not test-driven. So people make mistakes. Now, the thing is, we are really good at making mistakes. I used to think I was good at programming until I started doing test-driven development. Then I realized how many mistakes I make. And it's not measured per hour. It's measured per minute, really. There's a number per minute of mistakes. Maybe I'm just extra careless, or maybe I'm just human. I'm not sure. But the mistakes go undiscovered for quite a while. Maybe a couple hours, because I'm coding in the morning and testing in the afternoon, or maybe a couple of days, or maybe a customer has to report a problem that I didn't know about, a mistake that I made that I didn't know about. How long does it take to find the cause of a bug? Well, if it was this morning and I put it in, you know, my mind might still be in the problem. I might find it fairly easily. But also I might be clouded because I think it's doing one thing when it's really doing something else. But eventually I can find it, but it's hard to say how long that will take. You know, if I've never seen this code before, it's going to take a lot of investigation to figure it out. The fix might be very simple. Usually one line of code, a backwards if statement, an off by one error, oftentimes very simple. And then what happens when you fix that bug? You break something else. This is not good. How's your reputation now? Okay. Well, let's see if we could do what Edgar Dijkstra suggests. If you want more effective programmers, they should not waste their time debugging. They should not introduce bugs to start with. Now, what should we do, Dr. Dijkstra? Well, he didn't really give us a formula for solving this problem. He was pursuing the idea of proving software correctness, which is, I think, maybe beyond our capabilities at this time as well. But maybe we can approximate it, what Dr. Dijkstra was doing, to try to find a way to find problems sooner. And I think the practices of extreme programming help us to do that. It's taking some of these good ideas and cranking the dials up, right, to 11. I think Kent only cranked them up to 10, but since whatever that movie was, they go up to 11 now. These practices could help to avoid some of those problems. But I'm going to just focus on this. Test driven, it's not go write all the tests and then go write all the code. It's not don't do anything except write tests and code. No, it's a set of things, but this is kind of at the core of it. And why would we do it? Well, if you want to avoid this chaos and instead maybe have your development work like a fast-moving stream, avoid the chaos of the waterfall in favor of a fast-moving stream, not without ripples, of course, and some turbulence and some rapids to shoot, but could we get our work to flow? Right? This is one of the things we'd like to do. Spinal Tap, thank you. So here is test-driven development, which just showed you debug later programming. And one of the common things is we still make mistakes. But nicely, test-driven development puts a mistake right in your face. Right? So you put the mistake right in your face. It's the work you just did 1 minute ago. So you know what you were working on 1 minute ago. Even I can remember that. And you can find the problem and fix it. Now, sometimes when you, wrong way. When you make a mistake and you think you know what it is and you try to fix it, you break something else. The new thing works, but 4 other things break. When that happens to you, when you're learning test-driven, that's one of the moments where you say, it would have been hard to notice that. I wouldn't know. That would have been something I had to find later. I'm really glad I was just notified of that problem right now while I'm making the mistake. You can take the change out, preserve the 4 failing tests it just started, look at the problem again, try again to see if you can keep the old behaviors and the new. Because we're not working all the tests and all the code, we're working in a feedback loop, trying to get our working code to flow from what we think our code should do to what the product wants, what the product users want. Feedback loops. I've heard from people, it's like, yeah, but I already know how to program. James, why are you going through these stupid little steps? I don't work in stupid little steps. I've got 10 years experience. Yeah, I know. 10 years experience. Doing the same first year of experience over and over again with, new technologies learned and that sort of thing, but have your ways of working evolved? I see manual testing is still prevalent in the world. And what if you're using manual testing? Well, if you're doing iterative development, and if you've just finished the first iteration, I didn't want to use the S word, you've got to retest, you got to test the first iteration, and then when you finish the second iteration, you've got to retest the first. And after the third iteration, you've got to retest the first 2. And after the fourth, you can see what's happening here every time. And I'm being really nice by making a linear relationship here. I think it's worse than that. I think it's a multiplicative approach where it's going to get harder and harder to retest. So what do? Well, we shouldn't have to retest everything now. We should just test the things that we think we need to test. And guess what happens? We're wrong, because there's an untested code gap, which one day lightning strikes, and now we're having to fight those fires again. So we can't sustain development with manual test. We've got to start working with automated test to try to lower that cost of retest. Will it ever be 0? No, it will never be 0. But we could pay as we go, so to speak, and try to lower that and have a sustainable way of working. It's a challenge, though, to learn test-driven. It's hard to learn. some people think it's hard to learn. I know when I was learning, it's like I wanted to learn it, so it wasn't that hard to learn. But it's only taken me about 20 years, and I'm still getting a little bit better at it. But it happens to be fun, and that was a surprising thing too. It's the Pavlovian response that you can get by making little things work that end up leading you to a big thing that works. It can be very fun. I also ask people to tell me before they take my training class, what do you like about development and what don't you like about development? And one of the basic value propositions of someone learning and experience test-driven development for the first time is, what if you could do less of what you don't like and more of what you do like? And after a few days of doing it, not just reading about it, you read about it, you're going to read the good, the bad, and you won't know what to do. You got to do it to learn it, to understand what it could do for you. Maybe you'll find out that it could help you do less of what you don't like, debugging, dealing with bad code, hacking, and more of what you do like, producing a good product that works, not having to chase so many bugs. Now, I keep talking about this test thing, but that's not all there is, right? There's other things, refactoring. Now, this is not an exact quote from Martin Fowler. I actually misquoted him here, and I tried to get him to say this, but he wouldn't do it. He said the first part, any fool can write code the compiler can understand. But it takes real skill to write code that other programmers can understand. And so his work and the others that contributed to that book, Kent Beck and Ward Cunningham, and some other people, very revolutionary in how to deal with change. We've all done redesigns, and redesigns are very dangerous. And what refactoring is about is developing the skills to do iterative and incremental design changes, right? So we can keep the design young and flexible for a long time. So it's 3 skills. Artwork is one of my, well, I'm not much of an artist. There's my nose. Somebody once looked at that and thought, I think it was a frustrated golfer, said, is that a golf club that you wrapped around a tree? No, that's somebody's nose. So first off, we need to develop a good sense of smell, right? What is wrong with this code? Code smells, right? Common language and an understanding of what is a problem in code. Now, it's usually pretty easy for people to say, I don't like that. I wouldn't do it like that. That's not very helpful. But if we could name a certain code smell, like long method, large class, inappropriate intimacy, there's a number of names around these code problems, code smells. We need to envision something that would be better. Okay, so first off, what's wrong? What would be better? Don't just bring me problems, bring me solutions too, right? So what would be better? Well, it'd be better if this big method was maybe 3 smaller ones, because I can see these parts, right? So you could envision something better. And then we've done this for a long time. Then the other great innovation, I think, of the refactoring and extreme programming approach here is the incremental change, right? Step-by-step change. Don't do a big change and break your system. And if you can't put it back together, you can't deploy. How do I make behavior preserving changes one at a time and transform my code from a problem code, hard to work with code, to easy to work with code? And refactoring has some other uses. One is something called prefactoring. So you business people out there, your developers say, we need to do some refactoring, and your developers might mean, we want to redesign everything. Now, that's really not what they should do. What they should do is find a way to, maybe sometimes they should, but generally, you've invested in a working system. There's a lot of nuance there. We should evolve that code and recapture the design through refactoring, through envisioning better designs and refactoring towards those designs. I wanted to make another point, but I just slipped away. So your people will want to throw it all away and start over, but we want to get good at iterative and incremental changes to recover architecture, to make systems more flexible. Some other point that I forgot here, but anyway. So why does quality matter in our code? Well, the lawyers are coming. Eventually, they're going to find this lucrative business of software development as a place to go look for liability. Well, they've already done it. These are some old slides. Toyota, remember the unintended acceleration probably cost Toyota over $1 billion, if not more. There's blood in the water. It's not going to take long. You guys live in DC, many of you. It's not going to take long for the lawyers to kind of start coming for us. In development, if we don't get our act together, we might be led around by our noses. Government regulations and things, I think we should get our own act together so that somebody doesn't get it together for us in some way that doesn't work. So does your team do this? Does your team do test-driven development, refactoring, and other technical practices? If no, why? Do they? A lot of times, I like to do this talk to help the business people become aware of it, so that they can help take it and get your development people to start looking into iterative and incremental engineering approaches. I know you're all different. Like embedded systems, people tell me, yeah, we're different. We're special. Yep. Or people doing automotive software, they're special. Or health insurance, oh yeah, there's regulations there. We're special. Web development is special. Design automation, that's special. Financial software, yeah, you're special. I agree. It just doesn't matter though. It matters that you're special. That's a good thing. But the techniques of iterative and incremental development, you can find a way to use them. Right? Got to start using this cycle of Scrum to look for the problems and then go seriously look for ways to solve some of those problems. To get shippable code. What's in your way? So I think I'm about done here. I'll just kind of wrap it up. The three halves of Agile, like I thought for a long time, there are only two, but there's three. And I hear about, how do we motivate engineers and that sort of thing. And, what you want to really do is not demotivate them. Motivation is hard, but, motivation really comes from within. If you give people a good environment to work in, help them understand what's needed, make it okay to learn, right? So here's a programmer's life. They would just as soon be doing this, developing, creating something, solving problems, and doing something else. Look, they're even dreaming about it.